Oh, hi. Hello. So yesterday I was on a stream because I've got nothing better to do at the minute, and yeah, I went into this sort of analogy I've been batting around for a little while on LLMs and why they kind of suck, and yeah, I thought I'd do like a bit more of a formal go at drawing that out, I guess, or explain it a little better, a little more of a structured way, I guess, as why they're a problem and why the problem is ultimately unsolvable. And I'll go into more context around why, right? So my analogy is like using an LLM is like using a pachinko machine, right? Where we've got our desired outcome in our buckets at the bottom of our machine, right? Here's the things we want to get out of it. Here's our desire, right? And then each bit of compute, each bit of data is a peg in this pachinko machine, right? And each word, this is an analogy, don't forget, and each word is a ball bearing added to the top of that machine that we want to bounce. So we say we've got, this is our string, we drop 3 balls through here, this is what we want, and, you know, small context, you get a more better result, and some might fall out, right? Introducing that inaccuracy, that hallucination we talk about, right? So, but imagine this on a far grander scale. The buckets are billions near billions of combinations, near infinite combinations of desired outcomes, and the amount of pegs it has to go through is far larger, and the amount of balls you drop, each one of these is a token, right? Each token is a ball bearing, right? Think about that. Okay, so when you get that token rot, you're adding more balls, right? So as you add more balls through your pachinko machine, more of them will fall out of the range of your desired outcome, right? Because that's just the nature of it. It's a randomized system. You drop something in, it navigates its way through to find the result and drops it into what it thinks is the output. And it can't not do this because it's an LLM, it's a next word predictor. So it goes word by word and goes, well, this one, this is most likely here, right? Really, this is multiple pachinko drops in one go. This is easier to get your head around, right? So that is just the very bare basics of kind of how it works, I guess, with like transformer models. So that's the first part of it, and that's sort of like when we add more data to this, we are trying to add more pegs for a specific outcome, right? And an algorithm determines where these pegs are. So we want to say, you know, let's say, if we're to zoom in, this bucket is this is one single bucket. As we add data, we're hopefully saying, well, now we've got a much clearer path for these balls to fall through, right? Making it more accurate. This is data. But don't forget, this is billions and billions of parameters and so much data and so vast an amount of compute to get to this number. And you have to do this for each and everything. This is, again, an analogy, don't worry. For each and everything you ever do. But the problem is, with infinite combinations of outputs for this, right, you can never really do that. You're always going to have gaps for this information to fall through. And so you've got 2 elements of randomness here, right? You've got the coverage between point A, the thing you've asked for, your context, your tokens you're putting in, your desired outcome, and this maze of pachinko pegs it has to fall through, right? And the larger this gets, the more inaccurate this will always get, right? Which is why that context rot thing exists. You're adding more balls to the top of the pachinko machine. You're stretching what it can do, right? More and more of these will fall in places you do not expect, right? And sometimes they might fall miles away, all the way over here, right? Now, with each subsequent set of things, it also has to then find a new route. So when you find one of these and you go, well, okay, I'm going to find, I've consistently been going down a route that looks kind of like this, right? This is when it sort of changes tack and it starts to think that you are, you know, that thing that everyone must have experienced with all these LLMs is when it decides that one piece of the thing you've told it is the most important keyword. You could say something like, give me a list of all the dogs, but do fewer little ones, right? And I'd be like, well, I'm going to remove all the little dogs, or, you know, whatever, or I'm just going to call out a separate list of the little dogs. And in 10 minutes' time, when you ask me a follow-up question, I'm going to continue pulling out a specific section about how this affects your initial query about the smallness of dogs or any given thing in the meantime. You might at some point mention, okay, and their food, and it will change and decide that, you know, food is now the most important aspect of it, because it loses that context. It starts to veer off, right? If you notice, it does that. If you haven't, you either haven't used it enough or you're lying, right? And it doesn't matter how bigger or better these get, they always work that way. Have you noticed? So in ChatGPT 3, it did it. In Claude Opus 4.6, it will do it. In all of these models, they all do the same thing. It's what I call a failure mode, right? It's the way in which something fails. It doesn't change, right? Your likelihood of hitting it, because don't forget we've added more pegs in the interim. That's all we're really doing, right? With each successive generation of these, the technology's not changed. We're just adding more pegs to hopefully have more of these balls land in the right buckets. Yeah? Nothing about the underlying technology has changed. So you are still at the mercy of this system, because that's just how it works, right? In the context of coding, this presents an interesting problem, right? Because when we've got an example of how something should work, right, a lot of the stuff you do day to day in development is variations of the same thing, right? So if you're working in web development specifically, where it does the best in sort of like desktop software, etc., people don't have as much success with it, right? But the more sort of pattern-based things, the more pattern-based something is, it works kind of better, right? So I use Ruby on Rails. LLMs are pretty good at Ruby on Rails because it's very old, which means it's got a lot of data out there. What it looks like hasn't changed that much in those 20 years it's been around, and also it's highly conventional, right? So most of the time there's always one way to do something, right? Now the failure mode inside Ruby on Rails most commonly seems to be when you do novel things, right? Because Rails only covers you for the basics. Yeah, it's really flexible when it comes to you solving problems for novel things. It gets out of your way. So it's got a very hard line of, here's exactly how you should probably do this thing, but this thing here, we've given you a bunch of tools you can use, and you need to work this out yourself. But we will provide you as much information as possible to do a good job of this. It's kind of the if you boil down all of the bullshit, that's effectively what the system says, right? So when you get to a problem where it's one of these sort of issues, it can piecemeal find its way there, right? Through this process of going through this sort of pachinko machine to get you the right result. Eventually, if it's something mundane, like presenting an endpoint to an end user, right, or whatever, like the bare basics of general laying out like a CRUN app or whatever, right, or doing individual pieces, is either finding you a piece of this larger workflow. Let's change the color of this. A piece. Let's actually just do that. A piece of this larger workflow, or it has a reference of that larger workflow, right, which can piecemeal find its way towards. Okay. Now, with this in mind, each time you ask it something, you're throwing balls into a pachinko machine, and its tendency for that to drift, right, as that context grows. This is where you bring in like your skill files, your whatever MDs, whatever Markdown files you want to give it, which say, no, don't do this instead. And he goes, okay, well, I'm going to try and avoid these, right? So saying, okay, well, I know that over this side of the pachinko thing, if I drop them here, and I know there's enough pegs, right? It doesn't know anything, right? But this is the initial instruction. This is wearing thin now as an analogy. You say like, okay, the stuff I want is broadly over here, right? So when your MD file is basically saying is, well, just drop the balls this way to start with, or more of them this way, and then some of them this way. The thing that's still fucking dropping balls, right? So, and also it doesn't even necessarily reliably read the files. So every time you're like, and again, if you're one of these people saying, I've got all of these workflows and all of these skills and all of these orchestrators, every once in a while, the LLMs just ignore instructions. Outright. Again, that's unavoidable because you're always pouring ball bearings into the top of a pachinko machine. That's just how the system works, right? That's why occasionally it'll ignore your skill file, and adding more also adds more context, right? So when you add more stuff to here, you're saying, well, doing this, and you've got your initial request, and by putting it through a skill file, you are doing this. You're adding more balls still. You're increasing the amount of context you're using, right? The lower this number is, the better a job it will do. Okay, but also it won't necessarily even do a good job. Occasionally it will still just bounce and land in the wrong place. That's why I like the balls and pachinko machine analogy, right? It's still, you're at the fate of gravity to navigate through this maze, and you can't ever have enough pegs to always get the correct result out, right? So when you're doing development, when you say I'm working towards this larger solution here, right, let's go with this one. This larger solution here, okay. And then each time you add a little chunk to it, you're saying, well, okay, right, I've done this bit, I've done this bit, I've done this bit, right? Inside each one of these little chunks, if you work towards something, you're doing this, okay? And at one of these points, it might decide, you know, our next step is actually over here, right? Because there's this other workflow, and this step is similar between two of them. It doesn't know you're doing this because it can't, right? If you ask to do this up front, okay, so if you give it a lot of information, say just one shot this solution. Let's say this specific thing is, let's say, let's make something really simple, right? That it probably would do a fine job of in most systems. Let's just say serve an endpoint, right? Just an endpoint over an API. We're just doing that. That's all we're doing, right? And let's imagine we've got a hypothetical framework where this is complicated, probably something in Rust. Way, but no, let's say like this is like Spring, right? Where it's like not as straightforward, right? This is trivial in a lot of systems, but go with me. We're just going to use an example here, right? And let's say we've got this other thing here, which is like, I don't know. Fuck knows. Let's go with the second one I named. But let's say this action here, which inside there is one of these, right? Looks a lot like the example from here. And with each successive thing, so you're saying, right, each successfully filled bucket, I am trying to get to this solution. This is what we're trying to do, right? Okay. Next task, okay. Oh, this one's kind of similar to both of them. Well, that's sort of like there, but it looks like it fits there. Okay, and that one's there. Oh, and this one's now here. And now this is here. And now this is here. Then you correct, and you go, no, this is looking a bit weird. Can you do something else? And it goes, okay, well, this one's back here again. Or, actually, it could just even be one in here. You see? And you're trying to get it back to this end solution, which it has no idea how to get to. And that rot happens, right? So this is, and it can be so subtle. Here's the thing. And the less oversight you give it, the more it can deviate and eventually get lost. And if this thing is something not like serve an endpoint, but it's something much more complicated, like first check the user's orders, cross-reference by this obscure data we collect, then hit all of these services and then do a thing with that data, and then, you know, whatever. Your solution is something much more novel, right? There's no actual overall reference solution for what this is supposed to look like. This, instead of being something very well defined, is actually quite fuzzy, right? Those hits get harder to hit because it has no larger reference to ever land on. So all it's really got is just a collection of these little small fragments of its solution, which could come from any one of these buckets, that look similar, right? They quack like a duck, but they aren't. So, and that's where it becomes quite hard to track, because over time, you've introduced all of this crap, right? This is still tech debt. It doesn't feel like it is, but it is. And the less you pay attention to it, and all this time you're going, well, it does this quite well. In my experience, anecdotally, it does this quite well. And it's done a good job of this. I mean, we had to just sort of fix this one. Oh, that one didn't quite work. Oh, that one didn't quite work. Well, I mean, that one was almost there. I mean, yeah, and then we brought in a new system for this one. And then, yeah, then we brought in some new skills for this one. And this sort of starts to build up, right? It's either you do, and this has been borne out in studies, right? You do so much that it makes you feel like you're being productive. And actually it's just, you've offloaded the writing to it, but you're still doing the thinking and using it as a means of actually expressing your ideas. In which case, this can be very, very nil-sum, because when you're still doing all the thinking, which is how I tend to use them, to be honest, I give them enough, and I say very carefully, and people are like, oh, I've got multiple agents working in blur with orchestration, and it's like, you can't possibly review all of that code. Well, I don't need to, because I've got X, Y skills. Well, no, it can ignore the skills. It can ignore the orchestration, right? I had, like, someone the other day, I did a little tweet about it, and they went, well, your colleagues are non-deterministic too. And it's like, no, that's the point, right? They are, but the difference between an employee, they could be shit. That's fine, right? The difference is they can think beyond the thing that's directly in front of them. Don't forget, LLMs have no intelligence. This being anything, let's just say, like, I don't know, this box is write this function in JS. It doesn't know what JavaScript is. It doesn't know what a function is. It doesn't know you know what I mean, it doesn't know anything. And this is recursive, right? For each one of these, dozens of these have happened inside here as well, thousands, right? Recursively, all the time, to get to a point that looks like a plausible, thing, right? to do that, right? This is it. You're just throwing balls into pachinko machines to get to this thing. And it's got so much data it can do plausible things. It doesn't know. Each one of these data points, these are just pegs, right? This is just a peg. This is not add a semicolon, right? This is a peg. That means adding a semicolon becomes more likely, right? It's not actually anything. It's just a representation of what is ultimately add a semicolon, but it's not. There's no understanding there, right? So your colleague being non-deterministic, or your person reviewing the code, can do so with a purview of what this is supposed to be, and what they can do this and form clarity about what that end result's going to be, or at very least, they can iterate their way there, right? And there'll be decisions in between these stages that are very intentional. Right? You don't just bumble your way to clarity. No one does that. Okay, you might make mistakes, you might go here, we're human, we're people, it does happen. The point is, you can gain clarity over a situation. A system like this cannot do that. So when you work in it one way and you give up a very short leash and you say, I'm going to take this piecemeal, step by step, right? And I'm going to do all of the actual thinking and you're just going to do the code writing for me. Fantastic. Even then, it will still fuck up. It will still be like, you'll be sat there and you'll say, well, let's always write a plan. You've always got to write a plan first and make it action the plan. It ignores the fucking plans. Sometimes, not all the time, but enough, right? And there's that thing, or you might say, well, do precisely this. And it does almost that, or does something very marginally different. Because again, there's no knowledge. It's just referencing a picture of a thing that looks plausibly like the thing you're asking it to do, right? It's not used knowledge to do anything, right? It's a parrot. So what you're doing in this scenario here, you're saying, well, let's go piecemeal, let's ask it one by one, and we'll do the thinking. You're still doing all the thinking. All you're doing is not typing words out anymore, right? That's a problem you could solve with really good IDE tooling eventually, right? And there's there's scenarios where in this case, they can be super useful, right? Like if you've got a massive tedious list, or like you're in a scenario where you've got like, write a bunch of JSON by hand, right? Or a bunch of just like boilerplate. Fantastic. There's nothing for it to fuck up. It won't go wrong. It'll do it. And then you put it back in its box and you get on with your day. And fantastic. You've saved 20 minutes. But because it works in such a way that sort of you're encouraged to continue asking it questions and making it a dialogue and continue working with it, that eventually you go, well, it did really well at this thing. Well, can it do this? Oh, it sort of did this. Oh. And it wants to get you on this road when you're back with these people who are like, oh, let's have multiple coordinated agents doing a bunch of bollocks in sequence, and let's stop checking its work. It can check its own work. And it does this thing as well, which is it's changing the parameter of the problem to solve it, right? So, and if you haven't observed this, again, you've either not used them long enough, or you've not noticed, or you're lying. Where that example before, this is vague, and it's decided that actually I'm going to go off in this direction because I can't understand what I'm doing because I'm an LLM, right? I don't understand. So now I'm starting to find little bits that fit into this scenario of an end result, right? And I'll start to fill this bucket up, okay? Now, when you notice that this has started to happen, you don't notice it as a bug. It could be, it could be calling some libraries you don't want, or it might have added a dependency, or it might just be doing something in an inefficient way, whatever it may be, right? Whatever your particular scenario is, that's not sort of idiomatic with what you expect it to be doing, right? Or with the system you're using, for example, right? You know it's off course and you want to nudge it back into place. So you tell it, fix this thing. You can fix it yourself. But if you wait, it might continue to just distribute these parts of what you're trying to do into these different buckets. So eventually this becomes proper tech debt and quite hard to unpick. And it doesn't have any memory or knowledge. And this thing is now novel, right? Because it's doing fragments. It's now a novel solution rather than this clean reference it has to reference. It's now fuzzy, right? It also has no way of understanding how to get back to something with clarity. Okay, you can figure this out, but you have to take time to get back there. It's building you tech debt, right? So when you jump in and say, let's re-guide you, let's make you fix this thing, I want to get you back to here, right? You're putting more and more things in these buckets, and I've noticed you doing it. This is not quite what I want. Let's get you to fix it. And then it does this thing where it goes, okay, you've described to me. Let me pretend that I know what you're talking about here, because I can't actually confirm this, because this is vague. I don't actually know what this is because it's ambiguous. But I'm an LLM, and because you've dropped a ball on top of this pachinko machine, and I have to give you an answer, I'm going to make out like I know a route forward. And you go, excellent. Oh, thank you. Brilliant. And then there's a non-zero chance actually it does, right? But the more novel the thing you're working on, the less likely it is it's telling you the truth. Okay, but it will still tell you it's telling you the truth. Or you're asking about a fragment of this problem which makes you believe that it might be telling you the truth, right? So it might be referring to this, and you think it's talking about this, but parts of this, we're back here, right? Parts of this are still quite similar between them, right? So you tell it to refactor the problem. You tell it to fix this thing, this problem is created, right? You try to nudge it back on track. And you're still dice rolling, you're still dropping balls on the top of a pachinko machine to try and get it to make its way back to where you want it to be, which is this vague thing over here. And you'll notice a thing it does, where instead of saying, you have this problem, where it doesn't recognize a known solution or fragment of a known solution, it'll do this. It'll say, I fixed it. And it'll introduce a new box. And it'll say, well, actually, yeah, so I'm going to do this, right? I have a square-shaped problem. I'm going to change the shape of the problem to fit into the hole you've said, right? I've decided that actually it's this. Instead of fixing the problem you ask it to, it will change the parameters of the problem. And this is every time it says to you, you go, oh, well, actually, no, I know about some problems with this library, and like there's something about how I use the data later on, which I know is going to be an issue. Can you switch out? Let's chat about our options to maybe change to another way. It goes, oh, cool, absolutely fantastic. Yeah, I've ripped that out for you, and also I've put this in, and it's just like and just sharted something out. That's that, right? That it manifests in a load of different ways. That's changing the parameters of the problem because it needs to offer you a solution, because it's doing this, right? It's dropping balls into a pachinko machine. It needs to give you an answer, and it doesn't understand the next step because it can't. It has no means to understand the next step, right? And this is fine, because if you catch this, if you're working with it slowly, you can catch this and go, no, do exactly this, because you know the solution to the problem, right? You know where you're going, you know how you want to get there, and the toss-up becomes the time spent writing. If you've done something which is fairly mundane, and you're in this little flow state thing, and it's like, oh, it's done that right, it's done that right. Oh, hang on, this is a roadblock. And now it wants to do this instead of solve my problem properly. Do you stop, roll your sleeves up, just write the code, or do you carry on? You go, oh, I'll be fine. It's an ambiguous system, so you can't guarantee whether or not the answer it's going to give is going to be correct or not, right? No guarantees of any of that. So you just prompt it again, don't you? Again, you've got no guarantee, and it might present you a different one of these, but you can't necessarily tell because it's not going in a direction. It's not headed here. It's not moving in a direction. It's Brownian motion, man. It's just doing stuff. It's the worst junior you've ever met. Hasn't got a mind. So even keep it on a short leash, and you get to this point where actually you've either got to take over or you're prompting it so much. Some of that time you gained at the beginning when it successfully did this, then this, then this, then this, and it fucked this up, and then it fucked this up. But it did this and this and this. Oh, then it fucked this up. Do you know what I mean? And then a lot of the time that turns into a net reduction in time, and this has been borne out in studies as well. Like the actual productivity goes down, and that's the thing, right? It's not a case of they are useless. They are not useless, but they're so not enticing, right? Enticing is not the right word, but like, well, they are enticing. So there's a thing they do as well. There's this reinforcement thing. Every time it tells you, you go, oh, I'm thinking about doing this, and it goes, that's a great idea, fantastic, Jesus Christ, you're so bright, you're so clever. And it could be like, I don't know, like Grinder but for cats, or do you know what I mean? Or like, how about if something dispensed hammocks from a hole in the wall? And it duh. And it goes, oh, you are fucking mind of the generation. How do you do this? You're so bright. And you go, oh. I mean, I know I've been batting this idea around for a while. I'm pretty proud of it. Thanks. Someone sees my genius, and then it basically sucks up to you. It wants you to fucking carry on using it, right? And they're written in such a way that those prompts come back and they encourage you to carry on using it, so you do. So it's that thing of like, is something too shitty and dangerous to use? No. I mean, the thing is, if anything, I think the best rule of thumb for long-term success, and because this is like, can be hard to see, right? This sort of subtle shape change or deviation from course can happen, and this is code, right? You get to a certain point and you can't keep a code base in one person's mind anymore, right? So at scale, it's a bigger problem. If you want to vibe code a thing on a weekend, who gives a shit? Fine, whatever, fuck it. The point is, if you're writing real software that people have to use and has to exist and whatever for long term, this will always become a problem because it's the nature of the system, right? And no number of orchestration layers, of like skill files, of .md files or MCP calls or whatever will fix any of that because the system's always random. So it's fundamentally like a Monte Carlo thing, right? So if you know anything about 3D rendering, and why would you would have heard of ray tracing, right? And this is the foundation of all photorealistic rendering is the process of ray tracing, okay? And what ray tracing ultimately is you have your, let's just get rid of all this. You have your scene, right? Let's say it could be a photo, it could be a picture, anything. Let's just put an image in here. Let's just do like, oh, I don't know. Where's that gone? There we go. Any old random crap. Let's just do. Okay, it's a face. It's that lady. Look at her. Wow, she's happy. So yeah, this is our end result. Yeah, and then when we see the scene, we've got a geometry, a geometric representation of this lady. Yeah, so she's made out of these circles, and lighting is the thing that determines the realism. Okay, so what ray tracing does. It's from the camera's perspective, which is what we call the camera frustum, this thing here, the thing it can see, right, which actually from the side is a cone like this, right? There's your visual plane. Here's the place in which it exists, right? From this point here, what you do is you fire out a bunch of pretend photons, okay? You have geometry in the scene, you've got a distance between your camera frustum, this thing here, and the geometry, right? When it hits, it says, what color is the geometry underneath this line? Okay. Then you bounce that back to here, which is how an eye effectively works, right? You have certain wavelengths of light are absorbed by materials differently, and what gets reflected back to you is what we perceive as visible light, right? It's a facsimile of that. So when that gets bounced back, it says, well, what's the color of this pixel underneath this ray, okay? But it fires out millions of these rays, and it's called Monte Carlo rendering, right? Monte Carlo ray tracing. So basically you fire out n number, so hundreds of thousands, tens of thousands of these rays, okay? And then you have certain algorithms which filter out which ones are useful to you. If they fall outside this camera frustum, we don't need them. We can cull those rays. We don't need those, right? If this, let's say our lady's here and she's got something behind her. Well, this, we can't see through this. It's just math, so we could technically get this. We don't need this, so we want to cull these ones out of view. So those rays can go as well, right? And that's the same thing, right? So we fired out a bunch of random things, and we're saying, this is our bucket, okay? And we're going to cut out all of these rays until we get to a point where we've got enough to produce a plausible photorealistic image, right? Fundamentally, what you're doing with an LLM is not that dissimilar to this, right? These are your balls, your rays, fired out in similar quantity, to be honest, but there's two real critical differences, right? One, this technology, this setup, right, is a decade and a half older, 2 decades older, or like in terms of production, not like in concept, but in terms of like productization, right? That sort of R&D. And the problem they're solving, although this looks very complex, I mean, it is very complex. The difference is when you think about how technologies progress, right? So if you think about video game rendering of ray tracing, how bad that is. That's a mixture of reducing the number of rays, blurring the information. So effectively, that's kind of how they do it. They have a lower quality reference of the thing it's bouncing rays off, fewer rays, and a load of algorithmic magic in the middle to try and reconstruct something plausible from that lower density of rays, because this is incredibly expensive. If you fire infinite number of rays, right, there's more to it than this. There's like the surface material. Let's say she's made out of skin, right? She's got like, if you look, look at underneath on skin, right? You've got translucency, right? You've got what's called subsurface scattering, which then takes the rays and scatters them in a medium below. Or you've got transparency, and you've got things like index of refraction, right? So when light hits something transparent, light travels at the speed of light through a vacuum. If it travels through anything else, it travels slower. The medium it travels through determines how slow it moves, which changes its angle, right? It slows down, it reflects light differently. It's called an IOR. All that sort of stuff. It's extremely complicated. The point is, our end result is actually, it sounds, you go, fuck, that's so complicated, that's so crazy. Our end result is simpler because accuracy is about points of light on some geometry. And they only have to be so accurate to be plausible, right? So much of it's artistically driven. There's so much that goes in between point A and point B. You can't just fire infinite light and everything will look perfect. It doesn't work that way, right? But there's only so much accuracy you need to have this be really good. And actually, inside 3D rendering, you try and get that as low as humanly possible, and you manage it constantly to ensure that you are intelligently making use of your resources well, right? In terms of those rays fired, to keep the scenes light, to keep noise free, because noise is inaccuracy. Every time a ray fails, right, every piece of noise inside an image is a bad ray returned, right? It's effectively corrupt data, or it's an incorrection and a distribution of those rays, right? Which again is another thing. When you get noise inside a 3D render, have you ever seen it before? I don't know if you have. That noise is caused by an incorrect clustering of those rays, okay? Fundamentally, it's not that different what we're doing here, right? But our end result is something that only ever has to be by comparison. You're talking about the color of light. You're talking about an RGB value, right? A value of light, a color. That's it. You've got one thing. That's all it ever does. It returns you a color, okay? That's one dimension. When your Monte Carlo fire out a bunch of shit system, its end result is words, and semantically meaningful words, right? Again, the computer doesn't understand what green is. Couldn't give a fuck what green is, really. Doesn't matter. It's a number. These maths work out, and this is the number that comes back. Cool, I'll send that back to you, right? It's the accuracy of this is not relevant. But when those things are words and they have semantic meaning, a lot of the mechanisms, because this is not magic, it's just maths, it makes it it makes many magnitudes more difficult, right? And that's where we throw you can do this on you can get a CG image on a desktop class GPU nowadays in maybe, I don't know, a couple of minutes, right? And you go, wow, that's incredible. It's amazing. But then what the LLMs are doing is something similar, but at astronomically larger scale. And the thing you're trying to return, instead of saying, in the case of that 3D render analogy, it's not really an analogy, it's just in the case of 3D renders, you're saying we can fake all of these ways to pretend that accurate. That's what these techniques are doing, like real-time ray tracing in video games are just methodologies to create a facsimile of the end result, or a way to simplify the input enough to make sure you get something that seems plausibly like the correct result. But if it's not correct, it doesn't really matter that much. The consequences are actually very low, right? It could be something like, if you watch Digital Foundry, whatever, and they're pixel peeping, it'll be things like, and the shadows aren't quite as crisp as they or there's a minor ambient occlusion issue with the backlight, that kind of shit. It doesn't really matter, right? You're not producing, by the process of firing out a bunch of crap, your end result is you're not trying to produce semantically accurate information. And it gets compounded so much, like, I think it might become a meme at this point when someone goes like, we need a language that's really good for explaining what a computer does. It's like, we've got it. It's called fucking code, right? And you don't, all those things, like, we're trying to abstract away a lot of that complexity, but, there's always this thing of, like, you must have heard the sliding scale. You can have it fast or quick, but you can't have it fast, quick, or cheap. But you can't have all three, right? You can't have complex systems represented simply and capture their complexity without some reduction in their capabilities, yeah? And it's not so much that, that's always important, even with people, between you, even like meet between you and your end result, the developers or whatever, or the creators of those things, between you and your end desired result. Even if that's the case, the difference is they can do that with intent, right? They can pivot. They can suggest new things. They can come up with novel ideas. People can create. We're fucking incredible at it, right? We can do brand new things that no one's ever done before. LLMs cannot do brand new things. They can take the jigsaw pieces of other stuff and slop them all together. And we do the same thing, right? We have people are influenced by the ideas around them. But we don't just copy. We have an imagination. This is going to sound much more wishy-washy, but I'm talking mechanically, right? There's things that we can do these systems cannot. And there might, I'm not trying to say a computer can, that's not true, really. We don't know if that's true. Effectively, we are computers still in a way, right? Our brains are. But, you know, we're not magic. There's no magic in this world. There's just maths and biology. There is nothing else, right? Maths, biology, and physics. Everything boils down to one of those three bastards. It's, you know, it's possible. But the point is, the technology that we have does not do that. It's a thing that takes one input, produces one output, and it has a weight to say, this is the most plausible one. Tick, move on to the next one. That's all that is doing. Now, in the meantime, right, here's the thing. You say, like, these things are like, when, I'll give you an example, like, people talk about, like, fusion, right? Nuclear fusion, it's always 5 years away. You know why? It's fucking hard, right? It's really fucking hard. Really fucking complicated. And what that is, compared to sort of, like, take it, if you think rationally for a second, right? Fusion is about squishing enough atoms together to form some stable plasma, right? And then taking the energy from it. Like, on paper, is that a more complex or simpler proposition than a machine that can do everything? The machine that can do everything, right? Yeah, of course it's easier, right? Of course it's simpler, but you've got something that does a really good impression of that thing. It's still a mechanical Turk, right? Ultimately. But it's just a really good one. And again, it's not something that is actually useless, but the way in which it's been deployed, right, and capitalized, and market capitalized, the messaging around it is all very much, but it is this, guys. We don't know if it's sentient, or we don't know if AGI is around the corner, because of course they're going to say that. Anthropic saying the other day, we've got this new model. It's so good, guys. You can't have it. It's so good. It's so good. It's like, oh my god, it's so good. It's like, well, what did you do that's new? Well, we gave it a lot more data, and we spent a load of money on it on GPUs. Oh, okay. So no actual, you know, gilding the lily. Besides gilding the lily sort of type features, you just sort of throw more shit into this party trick, right? It's a really elaborate party trick of transformer models. Cool. Okay, because in the meantime, like, machine learning is just one machine learning methodology. There's others, and they all get lumped in under this AI banner, right? So things like diffusion, like stable diffusion, and all the image generation, they are not LLMs. It's a different technology, but they're the ones that get the most thing because they have the most. They're the flashiest ones, right? They're the ones that go, oh my god, this is great. Like, I have nothing against, like, I've been using a transformer model on a project to find word similarity, right? Because that's just all they do. That's all they do. It's just that as an ML technique, and it's absolutely fantastic. Love it. Great. No qualms about doing that. It's what it's supposed to do, and it does it really well. And it's like, it's just one technique of many, but this is one where, like, there's so much potential market capitalization for it that people have lost their fucking minds, and we've created a bubble around it. And it's like, and if you say that, if you call the duck a duck, right? Everyone's like, well, you're just a hater. You just don't know what you're talking about. But in my experience, like, well, no. But the thing is, like, you just got to keep engaging, like, your faculties in terms of what this thing actually does. And when you go, like, I hate magical thinking, right? There's this thing in engineering called AM/FM, right? Actual machines and fucking magic. A machine is something you can describe how it works in the parts, right? And even the magical thing, if it sort of works, but you don't know how it works, it's not useful yet until you can explain how it works. So think back to the advent of nuclear power and all the speculation around, oh, we have nuclear powered trains and nuclear powered cars. It's like, well, the radiation's probably solvable, right? Right? Oh, and the waste. Oh, and what if it goes super we'll figure this out later on. Right? Lo and behold, they didn't. And there's this massive gold rush, and this happens, you know, at different scales. all the time. And you figure out later on, it's like the foundation of sort of the Gartner hype cycle thing, where you go like, oh, there's all the promise. I am British, yeah. Yeah, you find out later on what the limitations of the technology are, and it evens out into like an even keel, and it becomes actually quite useful. But before then, there's lots of hype and speculation, and eventually all that drops away to being the useful core of the technology, right? And we're not there yet with LLMs. But the thing is, like, there's so many useful things they can do, right? There's an Angela Collier video. She's fantastic, which is basically, it's called AI doesn't exist, but it's going to ruin everything anyway. And yeah, she was saying about like this whole concept of like identifying black masses on MRI scans. It's fantastic. An LLM can just churn, or various machine learning techniques can churn through those images, find similar ones, and identify so many n number of similarities and discrepancies between images, and then present that information back to you. For summarization of information with a little bit of bullshit thrown in, because it has to, they are incredible. You know, with that point, you hand it back to a person to scrutinize the data carefully. But everything about how this technology is marketed to the general public tells you not to scrutinize how these things work. They tell you to think magically about it, and it just isn't. And when it's something that's like harmless, a lot of it isn't harmless, that's part of the problem. But when it's something harmless, it's fine. But when it's something like critical infrastructure, right? Do you let go of those reins? Should you? Will you forever? It's like, you know, it's not about being a hater. It's about being realistic. And like, you know, I don't know. My problem is mostly about marketing. Like, not that long ago. Let's go I mean, obviously, crypto's the big one, right? But let's go. That actually is also a complete fucking scam. But if you think about 3D print, I was thinking about 3D printing, right? And you probably don't remember because it wasn't on the same scale. And I actually got sent out to MakerBot's headquarters, right, in New York years ago, to go and film an interview with the CEO and the CTO about the future of additive manufacturing via 3D printing, right? This is in like 2013 or 2012, right, with the height of their power and making billions. And the company effectively collapsed a couple of weeks later. And that's when the big fall off with MakerBot happened. I was out there recording a video about how well they were doing, how perfect it was in their head office a couple of weeks before. It was mad, and the video never got made. Well, it got recorded, but it never got released. And it was fantastic because the language they were using was similar to what you hear now. Again, completely different thing, but that same irrational mindset. And if you cast your mind back just, under 15 years, like 10 years or so, there were scare stories about how the entire manufacturing industry was about to become obsolete because people could have 3D printers in their home and they could print any number of complex items. And 10 years on, they're really cool. And secretly, 3D printers are revolutionary. They really are. But the ways in which they're revolutionary are so boring that most people don't even fucking care. Like, you can manufacture shapes that are impossible with other manufacturing techniques through additive or subtractive, like through additive building, right? You can make like things out of novel materials you couldn't before because like the structure in order to hold them together to manufacture them doesn't need to be there. You can make prototypes of things incredibly quickly, right? Previously you have to send something off to a fabricator and make it out of aluminium. If you're working inside an engineering studio and you're working on like a part of a propeller of a plane, right, your lead time, and that has to be tested, it has to test for aerodynamics, strength, all these properties, right? But you're testing one aspect of it. You can, instead of waiting 2 weeks to get that back, you can have it in 3 hours on your desk to look at, right? You can test it with a set of calipers. You can, do you know what I mean? You can get something in a similar material. You can like do all sorts of material science stuff with it. There's so much you can do, and that's in the professional industry. And then personally, like for home people, it's still making like little widgets and doodads and bits, right? But also it's created this entire thing where people are now getting really good at product design, just lay people, because they got into this thing, they got into CAD, and now you can see these massive, awesome, elaborate things being made and distributed for free. It's fantastic. And you know what? It's incredible, and it is revolutionary, and it's pushing forward the envelope on engineering. But that's so fucking dull. That's not sexy. That's not you sat at your desk pressing a button and 3D printing yourself a sandwich. Because at one point, people were talking about it like that was going to happen. And it's the same with any technology. And it's mostly the same with LLMs because they do have a lot of potential, right? But the ways in which they're useful are so varied, so subtle, and so like minimal that, you know, and the nature of the tool and the way it's been deployed has the opposite effect because they've spent so irrationally. There is not enough market cap. There is not enough of a total addressable market. There is not enough money to cover what they've spent. It is a bubble. It's not a case of, is it? Isn't it? I don't know. It could go on forever. No, it can't. It just doesn't work like that. But the point is, there's been this stupid, you know, if you say to someone, right, a capitalist, you know, someone in a top hat smokes a cigar, wipes his ass with orphans, you know, whatever. How much is a bottle of milk? £500? That kind of guy, right? We've got this tool. Basically, it can do all the work of all the developers. It can do all your copywriting work. It can write everything. It can generate all the images. It can do all the media. And you go, oh, I've heard enough. And you've got your checkbook out. And you go, and how many money does it take for this to exist? Oh, just $1 billion. Oh, just $1 billion. Okay. All right. That sounds so promising. Very, very excited. And then the initial guy goes, well, do you not want to know some of the decent? No, I don't need to know anymore. I've heard enough. That sounds very promising. I'd like to find out more. Here's your £1 billion. And it's just been variations of that all the way down. And like eventually, you know, the people with money and not very much oversight of what actually happens eventually get wise via market movements and what sort of stuff. And they start pulling out money and then the bubble bursts. And that's sadly that's capitalism, folks. That's how that works. And we're not quite there yet, but we are on our way. And, you know, the thing is like for every $200 you spend with Anthropic, it costs them something like $1,000 in actual compute. They're not just losing money; they're losing money at this hilarious rate. And the route to making it cheaper, again, the actual real work, the real R&D under the hood to try and find, you know, new ways of doing this, to find new ways of creating artificial. Again, it's a very big problem. Look at quantum computing. How much do you hear about that recently? Right? It's a really complicated problem to solve. But people don't like complexity. People don't like big ideas. They go, well, break this down into something small enough I can understand. And then eventually you go, well, I put in words and the machine says the right thing to me. And it's like, but no, there's more to it. At least if you can't understand the complexity, understand that you don't understand it, right? That's what I do with stuff like this. I can't tell you meticulously exactly how the LLM works. I know enough to know what I don't know, right? Or I try at least to get to a point where I attempt to know enough to know what I don't know. Knowing what you don't know is really useful as a concept, but like, yeah, it's crazy. And you know, the R&D work to make something that actually is this system. Again, the problem we're facing is make a computer that can think about everything. Think though, not just replicate. Just parrot. And again, I'm going around in circles a little bit now, but you know, you take any one problem, and every problem has complexities, right? I've spent like several days figuring out where to put holes for screws in CAD models, right? Because the world's complicated, things are hard. Reality, things that need to work are difficult because there's all these things you can't account for. So, yeah. That's where you end up with it. So, you know, anyway, that's my I don't necessarily hate the technology. I mean, hate parts of it, but I'm not being a hater for hater's sake. But also, when it comes to writing code, man, it's like if you just know when to put it in the box, you know, like it just feels like just know when to put it back in the box is the best thing I can say. Or if in doubt, use scrutiny and keep your head on, because it's not great. It's not great. And like I've swung up until now, I've swung much more in the other way. I've swung back and forth on this one. Oh, is it okay? Is it not okay? And I've gone from hardcore despising LLMs to making use of them quite extensively at times, to then going like, actually, you know what? And recently, even with that short leash type attitude I've had in recent times, it finds way, and I'm going, oh, skill issues. Well, no, it's skill issues. I love that. That's the oh, that's so that must suck for you. Anyway, type attitude, which is so prevalent on the fucking internet. The point is, it's like, you dicks. Skill issues. Well, no, you're not engaging in the conversation, are you? Like, you know what I mean? It's ridiculous. It's a ridiculous thing. And when you start finding that, you know, with various different approaches, by sitting there and paying attention long enough, you end up saying, like, the world's not black and white. You know, you've got people in if you think about, like, your dev influencer people on Twitter, right? They don't ultimately give a shit if your product works or not. Their product is selling you their opinion, right? Don't give a fuck if your thing works or not. They will tell you whatever they need to tell you to make you click on their things so they get some advertising revenue. That's not reality, right? And then on the flip side, you've got things like engineering managers, heads of engineering, CTOs, and then people even further out the sphere of technology going, oh, use this thing. It works, right? And if your prerogative is only, I need to carry on getting paid, I need to keep my job, I need to make line go up, you'll just say whatever, right? When you have to take responsibility over the reality of what's going on. This is where I feel mostly, and personally, I don't give a shit if a company, like if Microsoft gets a bunch of, I mean, look at how fucked like Windows is. In part, that's got something to do with the fact they're using LLMs, right? But I don't care if a big company gets tech debt. I care about cybersecurity, right? Which is what this new Anthropic thing is supposed to solve, but how fucking can it? Let's watch it be underwhelming. But yeah, like, I care about the cybersecurity aspect of it. I don't care about them losing money. Fuck them. The point is, if you are like, and I think most people who are interested in this kind of thing probably are thinking about their own little pet projects or their own fun. For people learning to code, I fear for the idea of a good friend of mine, and I've sort of said something similar as well, as like, writing code is not the job, right? The job is problem solving, right? It's thinking. And if you continue to think and make use of tools that accelerate the speed at which you can write the code, cool, but you need to keep your feet on the ground. If you're someone who doesn't yet have those critical thinking skills or those abilities to think about and pull apart problems in really practical ways, which is what coding teaches you, right? Ultimately, that's all you're learning. That's a lifelong, it's not something you learn, you tick it off. It's a lifelong education of how to approach problems, pull them apart in a way to understand and come at good solutions, right? And systematically tear things apart. It's an incredible skill. No one's that good at it, right? But that's the chase. If you approach this as a career or as a hobby, even with that mindset of saying, I don't need to learn that, not even actively saying, if you're early on, you don't even think, yeah, you go, well, code, you might even think as simple as, I'm sure I thought like this, writing code or creating something like this is just a case of writing the words, having my idea come out on screen. And there's a lot of complexity underneath that, which is the real harder part of the job, and also probably the most rewarding part of the job. So, and to the hubris to think that you don't have to think about that anymore because some magical parrot box will do that for you. Evidently, it cannot. Is madness. But also, you're lured into this false sense of security. I think about like the it's no, fundamentally the whole vibe code thing is no different to Canva or WordPress, right? There's a thing, I've been doing tech shit since the 2000s, and I remember WordPress became a thing. I started out selling people Joomla websites, which at the time, I was young, I was like 20. I knew a bit of code and whatever. I was sort of, you know, learning. I knew some bits, but I was mostly a designer anyway, but I would sell people these Joomla websites, and it'd just be a template that I would modify, and I'd add some plugins, and that's great until they want to do something you don't know how to do, right? And then after a couple of years of doing that, my next job was working as an actual like software developer. We called them web developers back end, but it was actually front end development before that existed really as it exists today. It's like 2008. It started to become a thing, but it's an old school company. I actually had to roll my sleeves up and learn PHP properly and all this sort of crap and write HTML and that sort of shit. And like I stopped doing it and started to sort of like feel that the act of doing it is a little bit disingenuous, right? If you don't know the system you're trying to sell to someone, if I sell you if I sell you a tank and then you go and fucking fire a shell straight through a school, if I didn't know tanks could do that, I probably shouldn't have sold you the tank, right? You want a tracked all-terrain vehicle? Yeah, it's got this long tube on the front of it. I don't know what it does, but anyway, here's your all-terrain vehicle. Have fun. And if it breaks down or whatever, you know, you want to know what you're selling to people. And it didn't sit well with me, so I was like, you need to know. And since then, I had a problem. But when WordPress came around, it created an entire cottage industry of like these web development people, quote unquote web developers, who were these sort of like not bedroom coders, but like your mate down the road could do your WordPress website for 150 quid. Do you know what I mean? That kind of guy. He doesn't know anything. He knows how to run the install command and pick a template and then upload a JPEG, and that's the extent of his knowledge. Maybe a bit more than that, but not much more. He hasn't made that same decision that I think many other people, when I was faced with that setup, made a decision to do something else. But he hasn't. He's carried on. And because like it's a tool that reduces the barrier to entry to make stuff, right? To make functional stuff, it means more people can do it, right? But it also means that it becomes more fraught because they have less ability to manage it when the shit gets real. And the bigger the tools, the bigger the power tools they're using, and when it goes from being, I can install you some WordPress templates and plugins made by people who probably know mostly what they're doing, and when it goes wrong, I can't help you, to, oh yeah, I'll build you a full crazy SaaS app and pretend that, you know, you're a layperson, you don't care, you know, that why, for the reasons why this is bad, you know, you just know it doesn't work, or it does work, or you like it, you don't give a shit. And end customer, why should they give a fuck how you've built it? They'll just say, well, it doesn't work, right? It's not their prerogative to understand why it doesn't work. But when they come back to you, the vibe coder, and say, this is broken, and all you can do, and you found one of those examples I talked about earlier, we found like a novel little corner where there's no reference, and all it can do is sort of like impotently bat around it and not really find a solution, because one for it to reference doesn't actually exist in a way that's workable, because no one's quite written that combination of stuff before, or something close enough to it, or you've not found the right magic set of words to poke it in a direction to find the right bucket so it does that. Because that's the reality, that's what you're doing, right? You're fucked, because you have very little recourse. And instead of having a thing where you can pay a developer to pull apart your WordPress template and suggest a new plugin, tail between your legs, because I've had that before. People saying like, well, I manage WordPress, and I know you, man, I know you do like the other word development and whatever. Could you give us a hand with this? I've gone, what the fuck have you done? Because they copied and pasted stuff from Stack Overflow, a random form, into a fucking plugin they've got a free plugin from WordPress. Anyway, point is, you've built a much more complex system, right? These things are big, and you know, like, let's say hypothetically you build someone like, oh, I want my own what is it, CRM, right? And then to make a really shit thing is obviously very simple, but to make a bigger thing, and if you don't baby step your way there, you can go, well, I want this feature, I want this feature, I want this feature, and then they start getting into play, right? They start, the systems, each one of those features is an independent system, right? And then you start to say, well, I've got this system, and then this system, and this system, and this system, and then this system, and this one, and this one. And when you're actually developing, each one of these is a hedged bet. You go, well, I know what I need to do for this next feature, or at very least a rough idea of what I need to do. Or if you know often that these things do interplay with this other feature that's coming up, you'll make decisions up front, or choose an approach up front which supports it, right? You think ahead. The thing that LLMs can't do. They can do an impression of someone who's thought ahead, but they don't know what they're thinking ahead towards, because they have no memory and they have no foresight. They only present. The only thing they know is the next word in a list of words you've given it, right? So it can't do any of that. So you've got to hope that you throw a dart and you land on one of these. If not, you're fucked. So when these systems start requiring interplay, you've written like client, right? And you understand, well, clients need name or whatever, but then the nature in which that data has been stored, or let's say the way it's been processed, or the way it passes, you know, general development shit, the way it passes through a system that puts it in X state, which makes it incompatible with feature over here, right? Now, you're at an impasse when you go, well, how do I fix this? And as a developer, you can think about it. As an LLM, you go, well, fix it. This doesn't do this. Can you make it do this? And you just got to, again, prod at it until it gets there. And if it doesn't, and if it can't, where do you go? Who understands your code base? We give it to another LLM. Oh, makes sense, this code base. And it gets to a certain thing it doesn't recognize, so it just lies to you, right? If you've not had an LLM tell you that a library doesn't exist, or it gives you syntax that doesn't exist in a language you're writing. How do you, the vibe coder, know that the problem, ultimately, one that they consistently trip up on, they've gotten better, is a lot of the time, there's the turn it on, turn it off class of problems, right? And LLMs don't have the context to know that's a thing, unless they waste a load of tokens looking through entire code base to hopefully find a needle in a haystack. But a lot of the times, you can entire web application break, and the solution can be something as simple as restart Vite. And you have no paper trail to find. And it doesn't look like anything. And sometimes just to restart Vite, right? Now you know that. Or it could be something, it's not necessarily restart Vite. It could be, I don't know, delete your node modules folder and reinstall it. It could be, right? Oh, a symlink is broken in Homebrew. It could be, do you know what I mean? Restart a server. It could be n number one of these little very silly little problems. There's one very Rails specific one where LLMs consistently fail. There's a thing called stimulus, and there's a little function that runs. There's a little constructor that runs. It has like a little thing that registers all the control. You basically build a controller, and a little thing gets picked up in the build process, and it will rebuild your controller. But if you don't save it manually, if you slot a file in, it doesn't go through the build process, so it has no idea it's there, so it won't ever rebuild the index, you know, that loads in all the sort of thing that imports all the files for you, right? So you have to do that manually. LLMs don't know how to run that, so sometimes they'll remember to do it, and other times they won't. And it's that tier of problem, and you get no feedback because the file's not loaded. So if you don't know that's a thing, if you have no base of experience for the myriad little things that trip you up, shockingly, LLMs trip over those all the time. Or occasionally they'll just put in a stray semicolon, or they'll just put in a square bracket when they meant to do a curly brace, or whatever, which you do as well. But the thing is, you're sat there looking at it, you're looking at this file, and you go, why isn't it working? And you still waste, you the human, still waste the hour going, oh fuck, there's supposed to be a colon, a semicolon there, or oh fuck, this is an object, not an array, right? That's why that's failing. And so much of development is built around all those mitigation strategies and tooling over the decades. And you go, oh well, the LLM can just use them. No, it fucking can't, because it can't reliably engage any faculties because they do not exist. And you go, well, I'll write a skill that says, well, make sure you check through. And I've done this personally. I've gone, my process would go, write feature, write a plan. I would read the plan, all of the plan, validate the plan, please go build the plan. Next step would be, I've got a set of code standards and default checks to make sure that you meet the conventions of the system. Run that and give me a report of all of them, line by line, ordered by severity of the things that you've seen, plus anything you've seen, and reference XYZ, reference materials, and in the mindset of XYZ, don't lie to me, no mistakes please, etc, etc, etc. Then do me a report. I'd review the report and one by one fix the issues in the report. Yeah? Then I'd say update my tests. It'd update the tests. I would then check the tests. I'd say, okay, that looks right. Are there any, via another skill, are there any areas, let's do a full audit of the test suite to understand if there's any gaps that we haven't seen. Are we just on the happy path? And here's some examples that I've seen. Add to that list. Okay, fine. And then you go back to this step, whoop, to check your test suite. Then you check to see if your tests pass. And then I'd run this one again, which is the one that says, check this against these standards and make sure it's ready for production. Then I'd check the output, and I'd go through this until I was happy. And this would be one feature at a time. I'd carefully think about the scale of the feature before doing it to ensure it wasn't too broad in a system that's highly conventional and token efficient. The amount of times it's going to shit its pants and randomly one of these things will silently fail or miss something fucking obvious, and I have to go back in and say, well, you've missed this, you've missed all of this, you missed all of this, and I'll take over the wheel. And there's no amount of insulation against that. It just doesn't exist. It doesn't work that way. And the further you are away from the code, again, code bases grow quickly to the point at which you don't know every corner of it, right? Like, I think the project that I've spent most time working on isn't even that massive, right? It's something like 20,000 lines of code. A lot of those are tests, to be fair. It's not a massive application. And like even like the stupid shit on the internet, people are like, oh yeah, well more lines of code equals more good. No, it doesn't. That's more. It's like saying, well, I am building a car, right, and it's going to be the fastest car I've ever built. But it's got shitloads of parts. It's going to be so reliable. It's got fucking loads of parts. And I don't even know how some of them fit together, but there's fucking loads of parts on it, and it'll probably work the entire time. And it's like, no, fewer parts. Fewer parts are better. The best code you write is the most maintainable code you write is the code you didn't write in the fucking first place. So like, you want to have as few lines of code as humanly fucking possible, right? Because there's fewer places for stupid things to fucking hide from you. And you've got a system working in parallel that can make these mistakes, even on a very, very short leash. It will try really hard to make these mistakes. And you're doing it in parallel, en masse, and you're encouraging all your developers to whatever. And then that's the scale problem. Like, and again, part of that is fuck those guys to an extent. Whatever, who cares? But also, when it comes to like the individual doing this, if it's something that can just go in the bin, I've just made myself a little dashboard. Like, I was tempted. I want a little iPad that gets like, or like a little Fire tablet that gets stuck to my fridge, and it tells you on a Friday which bins you got to put out. Right? It says, and it's got another one which says, "Did you leave the cat out?" And it's basically a button that says yes, or is the dishwasher full? Yes. So you know to check it, and you can just see on the screen. Right? Just a little house dashboard thing. Right? Sounds like a fun evening project, weekend project. Just a laugh. And it's like, I really want to do it. It sounds fun. And that's exactly the kind of thing that you can do with an LLM, because once it's done, it's done. It's of no use to anyone. It's a little toy that sits in your house, not offending anyone. Cool. Perfect. I don't want to do it with that. I want to write it by hand because it's more fun that way. But yeah, perfect example of use of an LLM. Excellent. Gold star to you. Anything besides that, I've got a mate of mine who's like, he's like a design system manager, and he's written like a dashboard for home assistant, right? And it's like it's a throwaway thing. It's really, really cool. What he's done is really, really nice, but he doesn't have to maintain it forever, right? So he can put it out to people. Like, I've been working on like a little CSS library thing. All of the sort of functional parts I've written, but it's SAS. It's the easiest shit in the world. But there's these files that's just like 150 lines of CSS, repetitious. I'm just saying, well, spit out all these classes again, but change the word inside. You bet your fucking sweet ass I did that with an LLM, because I could have written it in 2 hours, or get it to spit it out in 35 seconds and review the output. And all it needs to do is change one word. And even then it kept trying to fuck stuff up. With the simplest thing in the world, copy this function, change the word. The function might be this, right? Make thing, right? Like that. Class. And insert your shit in here. I can't remember the syntax off my head. Insert your shit in here, right? Can't even fucking do that reliably. But which model are you using? Doesn't fucking matter. All of them. All of them. Some use more tokens, some use less, some are better. Whatever. The point is, the failure modes remain the same all the time. If it's something throwaway, it's fine. If it's something where you understand exactly what it's doing, it's kind of fine. As long as you keep your feet on the ground, cool. But the minute you just let it go off on its own, you're into this world of like letting it just vaguely poke away at problems because it can't think of the end result. And the more novel the problem, the faster it will happen, and the bigger the problem ends up. And the thing with software is there's only two things that give software value, right? I'm primarily a designer, not a developer. So there's an attitude towards development in a lot of cases where the adage is, if the thing you're doing is not technologically complicated, it has no value. Patently untrue. But there's a flaw to which how quickly an idea can be replicated. Yeah. So if you've got something you can read it. Let's say like the endless to-do lists. If you make another to-do list, you're doing something that isn't very hard in the first place, and you've just done another one, right? There's not much wiggle room to innovate on that. But if you do, let's take something like Things. If you've used Things before, Things is fucking fantastic. It's a to-do list, but just executed wonderfully, right? There's n number of small design decisions in the front end of the application, which differentiate it in ways that are meaningful enough for it to be a successful product. Or Superlist is another example. These are both to-do lists. Why do they sell and yours doesn't? It's because there's a better thought out. The design of it, the way you interact with it, gives it its value, right? And it's like, what's my point here? I'm slowly losing my point. The point is, like, yeah, the more, but then these both lead to novelty, right? So, do you know what I'm saying? It's fraught. It's fraught and it's dangerous, and you've got to be so careful. And the entire thing is people saying, don't be careful, lean in. If you don't lean in, you're going to get replaced. No, you need people to drive. And the thing is, like, if you listen to people on social media, they're all about, I just did this, I did this, because a lot of them are either got something to sell you, are quote unquote influencers, or all they're really doing it for is that dopamine hit what they see when they see the little heart icon next to a thing they've said on the internet. Or they're looking for a job and they want more views on their GitHub, right? People are complex beasts. But if you speak to jobbing, actual senior software minds, and some of the influencers, like I think like Primogen is a guy who I have very mixed feelings about, but actually sometimes he's just on the money, right? They're like, no, you got to be careful. You listen to like any of these really hardcore software engineers, they're like either still in the little hype funnel, or when they escape it, they go, oh fuck, and they wake up one day, gain their clarity back, and they start sounding like me. Not saying I'm like an amazing mind or anything, but they start gaining some clarity and they start sounding like me, because I've been through that journey. It's a journey everyone's on to realize these things are kind of shit. And you default back to this position, or you might go through a few times and end up back at this position. And the better the engineer, the faster it happens, I think. Or you've got people like DHH. Right now, the guy is a douche, but he's a fantastic software engineer. And his thing, and he has complete clarity. He's also a capitalist, massive capitalist. He has complete clarity on the problems of this. But the thing is, the guy lives in a mansion in Malibu. He doesn't give a fuck about the economic conditions outside of his own four walls. So for him, he's like, this is loads of fun. I'm having a laugh. I have nothing to worry about because I have like 3 Ferraris downstairs. He doesn't give a shit, and he knows that, and he doesn't even really make that much. Fair play to him. He doesn't even make it that much of a secret that he knows that. So, you know, he's like, well, these are really fun. For me, this is just a laugh because I have no worries in the world. But he behaves as if everyone else also lives in the mansion in Malibu because he's lost, you know, whatever. That's him in a nutshell, really. He's not fundamentally, I think, that much of a bad guy, just extraordinarily out of touch. And, but yeah, like, you just need to use your faculties around it. Like, these things are not useless. If you've got something disposable or quick, or if you need to save some typing, cool. The initial promise, I think we were all on the money about 18 months ago. But the problem is, you know, we're getting told that, you know, because the price is already going up. You see, like, everyone's sort of on the old internet moaning about the usage caps going down, right? So now Claude gives them less. And thankfully, my Claude subscription lapsed the middle of March, because I was using it to get ahead on some. And again, subsequently, I've not actually saved any time in the long run. I don't think. Hard to quantify, but aren't these things always? But yeah, and yeah, people going, oh, my usage is down, and Google's is as well, and all of them. And then, you know, OpenAI have sacked off their slot generator, and they're trying to find ways quickly to try and monetize this, because they lose so much money. And Google, who are probably ultimately kind of like sort of the winners in all of this, they're the ones who are going to be sweeping up at the end, clearing off the battlefield, taking all the spoils, really, because in part they're not in the circular funding bullshit that's going on, and they're running it all on their own hardware at probably much lower operational costs, I think. Don't forget, like, Google, like, have been at this sort of research for ages. DeepMind's been around for forever. So it's like, you know, they've got lower operational, still extraordinarily astronomically high. But when they are saying, Google, right, who have nothing, they don't need you to buy their AI services. They just need you to look at their adverts, right? They've got that on lock, right? They are the ones best positioned to benefit off this, as were before they fucked up, because Microsoft is so stupid. Microsoft are in a good position as well, as were Amazon, but they've both kind of fumbled because all they needed to do was make sure people carried on using their data centers, right? That's all they need to do. Between Azure and AWS, that was that thing. They all knew they had to sell some shovels, right, at the very top end. Google have done a great job of selling shovels because their business is advertising. Nvidia, fantastic job of selling shovels because they're selling the actual shovels, right? The GPUs. And then Microsoft and Amazon, all they had to do was make sure that the infrastructure spend went with them via Nvidia. And they have fumbled the fucking bag so hard. And you've got companies like OpenAI, which really were always destined to be bought by, like, I can imagine OpenAI become a much smaller outfit. They get purchased and absorbed by like a fucking IBM or Oracle or some shit like that, you know? Same with like Anthropic. These companies I don't think can really exist forever because like they have no, the R&D they do, they're in like a little arms race. The R&D they do is just throwing more data at the same technique everyone else is and trying to pull out more ways to get the same party trick. It's like you're cooking with, you're trying to make, you're running a restaurant but your main ingredient in your kitchen is spam, yeah? And there's only, you can make some nice stuff. Yeah, spam frit. You ever battered that shit, deep fried it? Fuck, it's good. But it's not going to be making desserts anytime soon, right? You're not putting it in a salad, yeah? So like, if that's your one trick, you can keep just putting it in a different dress, you know, as much as you want. It's like the dress from the episode of The Simpsons where Marge Simpson finds herself a Chanel dress in TK Maxx, and she's like, wow, and she starts cutting the sleeves off it. That's what they're doing, right? And in those scenarios, if you're just cutting the sleeves off the dress, the people manufacturing the dress are the ones who win. You aren't making dresses, right? So, and this is how this always plays out. Every single time, every sort of economic juncture in the course of capitalist history, it always kind of works out like this. So, but yeah, going back to my main point, this is going to get more expensive because it just is, and the amount of expensive it needs to get, they need to boil that frog in such a way to make sure that you're hooked or deep enough in unsolvable technical debt that you're reliant on this thing just to keep the lights on, right? Which I think is going to be a lot of businesses, which is an expensive problem to have, because I don't think there's enough money in enterprise for them to survive. So they need to be on the heavy enterprise scale of things and also on like the vibe code end of things, and everything in between I think is probably going to fall away. If someone said to you tomorrow, right, that your $200 a month Claude for your personal project that you're trying to get off the ground now costs $1,500, a wage almost, right? Like, not a very high wage, but like, you know, you're getting into hiring a person territory. They might produce more stuff than the person, so you might justify that to yourself, but also longer term, they can't get committed, they can't improve their skills, right? They can't bring new ideas to the table. And that first employee, they can do more for you than just write code. They can. If they're good, if you find a good person, they can do that. So, you know, I'm not saying you're going to be hiring a software engineer. If you hire them in a different country, you can get them for £1,500 a month, and they might also be great. But yeah, it's a weird time. But for you in your like little world of whatever you're doing at the minute, I would not recommend them unless you're really aware of the limitations and really what's happening and using a bit more scrutiny. Or you can just scream skill issues. You need more Claude files. You need to use XYZ VC-funded third-party wrapper around some node library thing. You know, aka you're a JavaScript developer. In the comments, if anyone sees this, then go nuts. But that's fine. Opinions like arseholes. We all got them, haven't we? But yeah, that's kind of like, that's it really. That's all I've got to really say. I've been going on for an hour and 18 minutes. I might cut this down to a video. I might not. And that was supposed to be the introduction to the rest of what I was supposed to be doing today, which was building a cheat sheet for Cocoon. So I might just do that off stream now because I'm bored of talking. And bye.